Hello, it's Bunton again with your visual functional mathematics at level 2, section 1 on numbers. Today's lesson is lesson 4. I'm going to look at decimals. You will learn that decimals are not whole numbers. You will learn how to put decimals in order, how to add and subtract decimals, how to multiply and divide decimals, how to round decimals, and how to use rounding to estimate the answers to calculations. And your keywords for this lesson are decimals, of course, rounding, estimating, decimal points, that's important, decimal places, again, that's important, and whole numbers. Not all numbers are whole numbers, that we know. Decimals are numbers with a decimal point. For example, 0.5, 1.3, and so on. They are used to show the numbers in between whole numbers. The number 32.95 is a bit smaller than the number 33. The number 32.5 is exactly halfway between the numbers 32 and 33. And the number 32.257 is slightly bigger than 32.25. You notice that as the decimal places extend, the number of decimal places extend, it tends to get smaller. The first digit after a decimal point shows tenths, the second digit shows hundredths, and the third digit shows thousandths. Let's look at this diagram. You can show decimals on a number line. What the line shows is at the top that you have two numbers, 30 to 33, and it shows the decimal points in between. After 32, reading from 32 to 33, you have 32.1. Look at the markings, the divisions. 32.2, 3, 4, and then 32.5, and then you go 6, 7, 8.9, and then 32.95. Note that 32.95 is exactly halfway between 32.9 and 33. And how do you read these decimal places? You read this as 32.95, not 32.95. I've heard a lot of people make that mistake. It is wrong. If you take just 1/10 of the decimal place and look at it further, that is between 32.2 and 32.3, you see how they are further divided. Between 32.2 and 32.3, you have another 10 decimal places. I'll say 32.2, 32.21, 32.22, 32.23, 0.24, 32.25, 32.257, that is between 32.25 and 32.26, all the way before you get onto 32.3. So decimals are a fantastic subject to study. Those of you who will be going on to do sciences and study computing will begin to see how these measurements can be divided into millions of places. How to put decimals in order. You might need to arrange a list of decimal numbers in order of sizes, just like you did for fractions. Put these decimals in order from smallest to largest. 1.02, 0.2004, 0.205, and 0.002. Example, look at the notes and follow them carefully. Put the numbers into a column, lining up the decimal points. The decimal point is important. That's what you use to divide, to show the division between the whole numbers and the decimals. The decimal points can be infinity. endless. Okay, put the numbers into a column, line up the decimal points. Make all the numbers the same lengths by filling in extra zeros at the end. Look at the numbers before the decimal point. Arrange the numbers from smallest to largest. Then number 4, if any of the numbers are the same, move on to the number after the decimal point. Arrange the numbers from smallest to largest. And below you see from step 1 to step 4 how they are arranged. Those numbers at the top, 1.02, 0.2004, 0.204, 0.002. Step 2, they are filled in so that they all have the same number of decimal places. Just read them carefully and you see what I'm talking about. 0.02 becomes 0.0200. This filling of decimal places does not change the value. It's just to make it easier for you to compare. Okay? Now, when you finish comparing them, you will be able to have them in order and you can put them in their original forms again. Step 3, once you fill in the blanks to 4 decimal places, then you can order them now, starting from either the smallest to the largest or the largest to the smallest. And then step 4, you do them systematically. You can do the whole numbers first, and then you do the first decimal places, the second decimal places from large to small or from small to large. And then finally, step 4, you have 0.0020, 0.2004, 0.2040, and then 1.0200. That is the order in which they are, but you cannot leave them like that because you need to put them in the format in which you are asked to order them. And the correct order of the numbers at the top are 0.002, 0.2004, 0.204, and 1.002. That's been placed in ascending order from smallest to largest. Practice question set 1. What is 55.354 in words? Which number is larger, 6.248 or 62.48? 2b, 32.658 or 34.648, 46.83 or 46.03. Don't forget to align, put them in number, fill in the gaps before you begin to reorganize them so that you know which is smaller and which is larger. Question 3. Which one of the following lists is in increasing order and tick your answer? So you look at it, in other words, which one is in the order in which it increases in value. And then question 4, put these weights in order of size from smallest to largest. So compare them first without the kilogram to confuse you, and then when you've done, you can add the kilogram after them. And there is your answer. All 4 questions, question 2A, B, C, and they have been organized for you. Question 1, 55.354. Up to question 4, 0.8 kilogram, 0.801 kilogram, 0.81 kilogram, and then 1.008 kilogram. That is from smallest to largest. Adding decimals. Write the numbers one above the other, lining up the decimal points. That's the first thing you should do when you want to add them. The decimal point is crucial. Make sure all the numbers have the same number of decimal places by filling in extra zeros at the end where needed. Write a decimal point on your answer line. Line up with the decimal points in the numbers above. Add up the columns from right to left, and remember to carry digits to the next column, just as you would do for whole numbers. When it's greater than 9, you carry it to the next column. Let's look at the examples here. What is 107.34 plus 52.837? Do not allow the number of digits to confuse you. Just concentrate on your decimal points. Okay? And look at how it's done. Line up the decimal points first, and then fill in the zeros. And on your answer line, make sure you put your decimal point before you start your calculation. Then you move on now and you do your additions. When you have more than 9, you carry it to the left, and so on. So 107.34 plus 52.837 is equal to 160.177. Subtracting decimals is the same principle, only this time you're subtracting, right? So you line up your decimal points, put your numbers, big one on top of the small one, put your decimal point in your answer line, fill in the gaps just in case, and then you can do your subtraction. So read points 1 to 4 and then do it. And this is what you have to do. What is 503.9 minus 42.78? Don't be fooled by the size of the digits you see. Just trust that you know what you're doing by, first of all, dealing with the decimal points. Line up the decimal points. Add your zeros. Put your decimal point in your answer line. Then you do your subtraction like you would do for whole numbers. When you have top number smaller than the bottom number, borrow 1 from the tens column, quote unquote, until you finish your subtraction. And then you write your answer down. So 503.9 minus 42.78 is equal to, practice question set 2. What is 88.464 plus 75.8? What is 451.64 minus 85.6? And then question 3, exam like question. Tom has 264 pounds, 0.98. Don't forget, pounds is a decimal currency. He pays in a check for 56 pounds, 23 pence. Then spends 39 pounds, 47 pence on petrol and 41 pounds, 42 pence in the supermarket. How much is left in his account? Follow the principle. Line up your decimal points, do your additions, fill in the zeros if you have to, fill in the zeros, and then do your calculations. And that's your answer. Question 1, question 2, and question 3. Correct your work. Celebrate if you got them all right. If you didn't, no problem. Learn from your mistakes. Just do the corrections, find out where you went wrong. Multiplying decimals. Start by ignoring the decimal points. Just do the multiplication with whole numbers like you normally would. Then, count the total number of digits after the decimal points in the original numbers. Write the decimal points to make the answers have the same number of decimal points. Write the decimal points to make the answer have the same number of decimal places. For example, 1.2 has 1 digit after the decimal point, and 2.45 has 2 digits after the decimal point. So 1.2 times 2.45 would have 3 decimal digits after the decimal point, because That's the way we adjust to make sure we get our answer right. Let's look at an example. What is 5.15 times 0.6? How many digits do we have? 5.15 have 2 decimal digits, and then 0.6 has 1 decimal digit, so you have 3. Let's see whether I'm right. Ignoring the decimal points, do the whole number multiplication. 515 times 6 is equal to 3090. Count the number of digits after the decimal points. So 5.15 times 0.6 has 2 plus 1, 3 digits after the decimal point. So once you have your number, you'll find out that your answer is 3.09. Ignore the 0 after the 9 because usually you don't use it if that is your answer. You can leave out any zeros at the end if you're not told how many places to give your decimal answers to. In an exam, usually you have an option if you're told, but if you're not told, you don't have any option. Dividing decimals by a whole number. When dividing a decimal by a whole number, set the question up as you would for whole numbers. Write a decimal point on the answer line directly above the decimal point in the number you're dividing. Then do the division using the same method as for the whole number. What do they mean? Let's find out. Examples. An 8-story building is 37.6 meters tall. Each floor is the same height. How high is each floor? And the clue there is each floor is the same height. So, you need to divide 37.6 by 8. Okay? 1. Write the division with the number you're dividing. B. Put the decimal point right above the 1 in the number you're dividing, as you see on step 2. And then step 3, do your division. Use the same method to do the division as for whole numbers, but do not forget your decimal point. So each floor is 4.7 meters high. Dividing a number by a decimal. Write the number as a fraction. The number you're dividing by goes on the bottom, and then the number you're dividing is at the top. Remember, a fraction is a division sum, so it follows. Multiply the top and bottom by 10, 100 or 1000 to remove any decimals and leave the whole number on the top and bottom. You must multiply the top and the bottom by the same thing, bringing it to its lowest factor. Do the whole number division to give the answer. Example, what is 45.18 divided by 0.03? Write the numbers as a fraction. In other words, 45.18 divided by 0.03 is written as 45.18 over 0.03 as a fraction. Okay? If you don't understand what I mean by a fraction, imagine that those decimal points were not there. You have 4,518 over 0.03. That's less than 1. Okay, it's the same thing. But make sure you put your decimal points right. Multiply the top and bottom by 100 to get an equivalent fraction. So you're trying to make them into look like whole numbers. So 0.03 times 100 is equal to 3. 45.18 times 100 is equal to 4,518. I'll go through that again. 0.03 times 100 is equal to 3. And then 45.18 8 times 100 is equal to 4,518, as you can see in step 2 there. And then in step 3, you do your whole number division. But when you finish, you need to make sure you divide again to make sure you make them back into decimals. So 45.18 divided by 0.03 is equal to 1,506. Remember, you're dividing whole numbers by a fraction, a very tiny bit. It's like saying divide 150,000 by 1 or by 2, as the case might be. So the number of times it will go into it will be bigger. Practice question, set 3. Calculate 3.48 times 1.6. Don't forget to add your decimal places. B, 82.3 times 5.9. Question 1C, 41.08 divided by 4. And then 1D, 78.4 divided by 0.8. Question 2. Kaiko works 37.5 hours a week. He needs to divide this time equally between 3 different projects. How many hours should he spend on each project? Question 3. An office has 8 people in it. They have a total of £20, 40p to spend on lunch for the whole office. How much do they have to spend on lunch per person? And that is your answer for question 1, A, B, C, D. Question 2, in hours. Question 3, in pounds. Check your answer, do your corrections, and learn from it. Rounding and estimating. You can sometimes get an answer with lots of numbers after the decimal point. Instead of writing down the whole thing, you can shorten the answer by rounding. Rounding off decimals, in other words. How do you do it? To round a number to a given number of decimal places, first identify the position of the last digit. For example, if you're rounding to 2 decimal places, it's the second digit after the decimal point. Step 2. Look at the digit to the right of this. It's called the decider. So you have to find the decider when you're rounding up. Okay? If the decider is 5 or more, you follow the principle. Round up the last digit. If the decider is 4 or less, leave the last digit as it is. And number 4, don't write down any digits after the last digit, not even a 0. If the last digit is 9 and you have to round it up, you would need to round 9 to 10, which means you move over to the whole numbers, or as the case might be. This means that the last digit becomes a 0 and you add 1 to the digit to the left of the last digit. Here's an example. 1. Round 2.842 to 2 decimal places. There are 3 decimal places there. 2 is less than 5. So you leave it at 2.84. Now, the second example, round 5.398 to 2 decimal places. 8 is greater than 4, it's 5 or above. So because of that, you'll have to round the second decimal place, but that is 9. So that becomes 10, and you move that 1 over to the 3, and rounding up will make it 5.40. Okay? The question asks for 2 decimal places, so you need to include the 0 at the end. it's not just 4. So read your questions carefully. If it asks for 2 decimal places and the second decimal place is a 0, you have to put it there. Rounding to the nearest whole number. You can round to the nearest whole number in a similar way. This time the decider is the first digit after the decimal place. For example, to round 25.65 to the nearest whole number, the decider is the 6. So 6 is greater than 5 is greater than 4. So this means that 25 becomes 26 because you add 1. You don't need a decimal place. And in real life, you have to help to make certain decisions. And this is where rounding comes into its own. To round to estimate the answers to calculations. You can check your answer in tricky calculations by estimating. To do this, round each number in the calculation so that all the digits, apart from the first one, are 0. For example, to the nearest whole number or the nearest 10. Then do the calculations using the rounded numbers. If your estimate is close to the answer you get, then your answer is probably correct. But there are rules you need to be very strict about. Let's look at this. Vishal earns £3.80 an hour for a paper round. One day, his round takes him 2.25 hours and he gets £5 in total. Estimate how much Vishal made from his paper rounds that day. First of all, round each number so that all the digits apart from the first one are zeros. So £3.80 will be rounded to £4. That's one. And then secondly, 2.25 hours will be rounded up to 2 hours. And then £5 stays the same because there is no decimal place. Then do the calculations. So £4 times 2 is equal to £5, which is equal to £13. Vishal made about £13 from his paper round. Note the word about because it's not exact, it's an estimation. Okay? Alright. Now you might say rounding up £3.80 to £4, but 2 hours 25 minutes to 2 hours might be unfair, but don't forget you've already rounded up the rate from £3.80 to £4. So they tend to compensate each other, and this is just an estimate of what he will get for quick decision making. Practice question set 4. Round these numbers to the given number of decimal places. A. 1.024 to 2 decimal places. B. 3.57896 to 1 decimal place. Don't forget, find the decider before you do it. Round each of these numbers to the nearest whole number. Again, the decider will be the first decimal place. Question 3. A racetrack is made of 3 sections. Daniel does a lap which takes 18.638 seconds in sections 1, 33.392 seconds in section 2, and 18.779 seconds in section 3. Estimate how long Daniel took. Remember, you need to round up each of those figures you have before you do your calculation. Otherwise, you're not sure whether you'll get it right. Question 4. The formula for the area of a circle is A for area equals PR squared. That is pi. P is for pi. Okay? Where A is the area and R is the radius. Estimate the area of a circle where P is equal to 3.142 and R is equal to 8.6 centimeters. And that is your answer for questions 1, A and B, question 2, A and B, question 3, and question 4, all in centimeter. Question 4 is in centimeter squared because it's an area you're looking out for. Before we go, let's check what we've learned. You now know that decimals are not whole numbers. You know how to put decimals in order by comparing decimal places. You know how to add and subtract decimals. You know how to find decimals of whole numbers. You know how to find decimals of decimals. You know how to round decimals. And finally, you know how to use rounding to estimate the answer to calculations. That is our lesson for today. Take care of yourselves, and I'll see you next week. Bye.